Okay, everybody, welcome to week 3. So this is NRGY 242, solar, thermal, and wind. And I just wanted to, catch everyone up on where we are. There was a question about whether or not you should bother buying the textbook, and my advice on that would be to, yes, buy the textbook. There were none for sale in the bookstore. They're typically more expensive, so I didn't bother. There's lots of versions out there online. The Piggott text itself, it's just sitting right there. The whole thing. It's the smallest of the 3 textbooks. The reason I picked 2 separate wind textbooks, the Piggott text is kind of like DIY, kind of backyard ballistics, just get her done on the cheap. The JAW textbook is more engineering. There's equations, some calculus in there. We'll do a little bit of that, but I figured, unlike the alternative fuels textbook, which I think hits around the money in terms of the appropriate level for a sophomore level class. Very challenging to find a similar level textbook for wind. The solar textbook. I've got, I don't know if I've got, let's see what I do have in there for the online version. I do not have anything copied, but Serenity has gone to the trouble of making a few chapters of the solar thermal available. The reason I call it, the reason for combining the 2 topics in one course, I think if we had just a wind course, if we had just a solar thermal course, we'd have enrollment issues. The motivation for including the 2, some students are more interested in the solar thermal aspect. Some, I've had students come through here and find careers in the wind industry. Another motivation for including them in the same course is they're intimately related. When the sun shines and air gets warm, it creates wind. So those are the 3 motivations for including both topics in the same course. So just want to go over the syllabus one more time, because I've got a fuller classroom. Oh shoot, I'm sorry. I still need to update this. We meet, and I apologize for that. I thought I'd fix that. We do meet Tuesdays and Thursdays, not from 8 to 9:30. We're meeting just on Thursdays from 2 o'clock to 4 o'clock here in HBO 6. So I apologize for not updating that. Everything else is the same. I want you to be sure you know what the solar constant is, 1,000 watts per square meter. We'll use that frequently. Laws of thermodynamics to look at solar thermal and or wind systems, whichever one you decide. You'll be exposed to both, whichever one you decide to focus on. Factors that affect both, being able to evaluate resources on a site-specific basis for both wind and solar. We're going to be able to perform a thermal load analysis by the time we're done. Same thing with electrical load, so you can properly size a system. And Tim's going to go through this in a little bit, but describing, specifying site equipment appropriately. We're going to work towards getting our new renewable energy trailer off the ground. That's critical for that. Estimate of energy output and cost, something that frequently stands in the way of renewable energy systems is just their availability and sort of perceived payback time. You'll use some tools of the plumbing and electrical trades for safe practices. We will do some labs with both of those. I think you've already begun to do this, but get in touch with local installers and then do one of these 3 things as a project. And Tim's going to walk you through that here in a little bit. And we'll need you to... Yeah, Passive House, this was a building standard that was developed in Germany, and a lot of times houses will be rated in BTUs per square foot per year. So if you've got a 2,000 square foot house, it's going to take a certain number of BTUs or a certain amount of energy to heat the house. You could also do a similar thing for an electrical analysis, how many kilowatt hours per square foot per year. Once you know that, once you know either the thermal or electrical requirements or both, you then size your renewable energy technologies appropriately. How much wind do I need? How much solar PV do I need? How much solar thermal? If you've got geothermal in there as well. The passive house standard is more or less one where your loads are greatly reduced. There's enough insulation in the house that you're not constantly heating and cooling it, and you're able to generate or produce almost all of the energy that you need on site. Yeah.
So basically, you use the natural features in the design of the building. So it might be a trauma wall.
Yep.
It might be all south-facing windows to maximize what you're getting from the environment, not providing with electricity or oil or whatever.
Right. So if you remember back to Energy 102, there were several separate forms of lighting versus heating. Tim just mentioned the trauma wall as one. So, and you can even see right now we're looking up at fluorescent lights lighting rooms with an opaque roof above us. So it's a one-story building. The logical step would be, why not just poke a hole in the ceiling so you don't have to turn the lights on? And then you've just reduced the building's electricity load. Same thing. There's a lot of south-facing windows over there. Why not have more south-facing windows? So when it's December 21st and freezing cold outside and the sun is shining, let some of that light in to turn into heat for heating the building.
Real similar to the LEEDs. If you look at LEED building structures,
yeah,
they're kind of on the same page.
Mm-hmm. And so there's two philosophies. There's one is to increase the efficiency, so reduce the demand, and then the other one is to move towards renewables, so you're not relying on fossil fuels for heating and cooling.
By increasing efficiency, you reduce demand for a product? But if it's more efficient, don't more people want it?
Well, depends. I mean, it kind of depends on, well, again, getting back to cost, if you can afford to, keep all the lights on and keep the heat turned on all the time and keep the AC running in one half the house and heat, then no.
I think you're actually using a different definition of demand, or a different use of the word demand. Thus, demand would be your electrical. If I put in an LED light, my demand is reduced. My demand for electricity is reduced.
Right.
Not the public's demand for LED.
Oh, there we go.
Oh, I see.
Yeah.
Okay. So the demand is how much power is expected to be used?
Yes.
Okay.
Yeah. Yeah, it's the physical demands on the system, how many watts are coming through it. Efficiency in the case of lighting, efficiency is how many of those watts are being converted into lumens versus, public demand for a certain type of technology. Okay, so, everyone's been through 101, had enough math to be dangerous at this point. You should have a multimeter of your own. It'd be great to have a kilowatt meter as well. There's the solar thermal text. Here's Pigott, and here's JAW. Those are the three texts. And like I said, we've got online versions available of each one of those. Okay. So assignments, yeah, Tim?
I touched on it once. Your multimeter,
Yeah.
the $7 one from Harbor Freight works just fine. If you watch their ads, occasionally they have a coupon for a free multimeter.
Yeah.
So you buy something else, so go buy a bundle of 100 wire ties for $1.99.
Get your free Harbor Freight multimeter.
Fancy, expensive ones do.
Yeah, nice.
Except lay in the back of your trunk at 105 degrees.
Yeah, don't cook it in your car.
Yeah, they don't like that. None of them like that.
Okay.
I find it very different.
Yeah, so, the assignments and participation are pretty self-explanatory. Just, log in at least twice a week, so you're up to date on what's happening in the course. I'll have you reading either from the textbooks or the internet or a combination of both, posting to the discussion board, and just participating in that. And we'll go over that each week. And, as I move through this lecture, you're held accountable for whatever I say in lecture. Class project, Tim's going to show an example of that here in a little bit. One example of something you can do. Here's the drop add policy. Like I said, you've got until Monday of next week to drop or add the course. Just stay in touch. Do my best to answer emails. Use your University of Montana email. So here's where we are right now, and I'm happy to cover a little bit more theory because I think there were a few struggles with the first test. I'm happy to go back and cover a little bit of that. Tim's going to go over the design review here with you in a little bit. I'm just going to pause the recording. This year we're just doing 2 hours of lecture per week. I find if it's 3 hours, it's just kind of too much. So we're doing 2 hours of lecture. We're going to focus a lot more on the hands-on. No shortage of opportunities for that. So if you've taken the practicum already, you're familiar with what happens with our hands-on activities. This is an opportunity to enhance your skills in the hands-on, build your confidence in building, testing, and taking data, and like I said, sizing a system. So I'm gonna pause it here. I'll let Tim show you a design, possible design for you to do for your project, and then, we'll go from there. So, yeah.
And there's an actual assignment. It will be a paper due at the end. So.
Yep.
How many other folks do we have online?
Well, yeah, it's a good question. I think there are 10 students in the course.
So they probably should see that too, so they know what's going on.
Yep. Well, this is all, I'm going to get you up in front here.
Yeah.
So, yeah.
And we can open up that document too.
Yeah, I'll let you do that. So, anyway, so I'm going to pause the recording and let Tim take a stab here.